so let's keep going, and we're going to talk about this example one. So at the 0.5 significance level, does the monthly ozone density in New York have identical data distributions from May to September of 1993? Okay, so here are my hypotheses. The null is the medians for the months are the same, and the alternative is the medians for the months are not the same. And remember, we're using medians because in the first video, you saw that the distributions were different. Let me show you right fast. See here, if you haven't watched that video, go watch that video. And I kind of have something out here that talks about how May has an outlier, June has an outlier, and that fourth quartile is so tiny. It's that little tiny line right there. July's okay. August, this quartile right here is skewed, and then September we have outliers and a skewed fourth quartile. Okay, and again we can look at descriptive statistics. So to run this test, I'm going to go to Minitab. Okay, so what I'm going to do is I'm going to go to Stats, Non-Parametrics, and I'm going to go here to Kruskal-Wallis. I'm going to put in, let me do it for you, ozone for the response, and then month for the factor, and I hit OK. So it gives me the descriptive statistics again, and it gives me the medians. And here, when we just see it this way, yeah, we can compare them, and they're all different. Okay, I mean, well, September and June are pretty similar. May, I'd say okay, but look at July and August. They're way up there. So, I mean, July is almost double, or excuse me, the triple the median of May. So yeah, something's going on. So then it gives me actual test part. So the null, it shows me that all the medians were equal, and the alternative, at least median was one is different. That's basically what our hypothesis said. I just said it in a different way. If you like the way that Minitab says it, you're more than welcome to put it that way. Whatever makes it easier on you. All right. So we're going to do the not adjusted for ties method. I'm not going to go into that all the time because it's a little bit tricky. But if you look at the values, they're pretty much similar. So degrees of freedom are 4. Remember, that's my number of groups minus 1. So the H value is what we use for the Kruskal-Wallis test. It's 29.25, and my p-value is 0. So I got everything I need, really simple, from that test. Okay, and again, if you get stuck, PowerPoint has it. And I put this. All right, so let's go conclude it. So remember, we want to conclude our hypothesis. We got the 0.05 level of significance. So since my p-value was 0, so since 0 is less than 0.05, I'm going to reject the null. Remember, people eat fish from the river Nile, reject the null. So the medians of the months are not the same as true, which is my alternative. So how can I conclude at 0.05 significance level, the monthly ozone density in New York does not have identical data distributions from May to September in 1973. And again, it makes sense. Remember, we talked about ozone as, pollution can affect it. And in the summer months, pollution does go up because of there's a lot of factors going on with that. But this is what this showed us. Basically what I did, I ran an ANOVA for non-normally distributed data. And there's a lot of talk about, is this a better test than ANOVA? It's very, very similar, and it could also give you almost the same exact results. I just caution, and I use a non-parametric, and when I really do this in the real world, I also do an ANOVA just to check myself. But for this class, what you're going to do, look at the distributions of each group, and then decide to either do ANOVA or a Kruskal-Wallis.